By the way, my name is Bob Martin, in case you didn't know. Why are we here? Now, the long-range answer to that question is that there is a fundamental asymmetry in the weak force of nature that causes matter-antimatter relationships to slightly prefer matter. So that after the Big Bang, when equal amounts of matter and antimatter were created and then began to recombine, there was a small residue of matter left over, and that's us. So that's kind of the long-range version of why we are here. But there's a shorter range question. Why are you and I here in this room today? What is this craftsmanship thing? Interesting choice of word, thing. Why is this craftsmanship thing something that attracts 300 people into a room? What is software craftsmanship? Who are we if we are members of the software craftsmanship community? What are the values that we hold? Why are we here? And this is something I have pondered for a very long time. What is it that draws a community of software developers together to meet in a room like this to talk about craftsmanship values? How many of you are programmers? Damn. That's like unanimous, man. Everybody here is a programmer. Are there any managers in the room? Out. What? Not bad. Okay. So we are here because we share a set of values. And that set of values includes the desire to be proud of what we do. We're programmers. We write code for a living. And for many, many years, there was very little pride in this. Oh, we could build products. And I'm sure that some of you have been proud of the products that you have participated in. But that's not really the question. The question is, are you proud of the way that you built those products? Did you go home every day and look in the mirror and say, today, I did a really good job, even if what you did was to delete everything you worked on that day? At the end of the day, you just threw it all away and you went home and said, you know, I did a good job today because I got rid of a bunch of really bad options. How do we become proud of the way we work? Not of the products we produce. It's important to be proud of the products we produce. But it's also important to be proud of the way we work. People call this workmanship or craftsmanship. We are craftsmen, or we're members of the craftsmanship community. We are craftspeople because we value the goal of being proud of the way we work. Who else do we want to be proud of the way we work? Well, we want everyone to be proud of the way we work. We want people to be able to observe the way we work and be struck by the discipline and the orderliness and the care and the craftsmanship in the way we work. And why do we want other people to share that pride with us? We want other people to share that pride with us because it engenders trust. Your managers, your employers, the people you work for, your customers, if they are proud of the way you work, then they trust you. And if you are struggling because a problem is difficult or because a deadline was unreasonable, they trust you. They see the way you work. They see the effort, they see the discipline, they see how you value your their own self-respect, and they trust. A very long time ago, nearly 20 years ago, Kent Beck said something that struck me, and it stayed with me all this time. And it occurred at the Snowbird meeting where we did the Agile Manifesto. And he said the reason that he did extreme programming, which was kind of the core of Agile, the reason he did extreme programming, the reason he promoted it, was to heal the divide between business and technology, heal the divide between programmers and business. And that's what we want. That's why we want to be proud of the way we work. We want that divide not to exist. We want to be partners with our employers. And we want our employers to consider us as partners, and we want to consider them as partners. We want to have a shared goal and a vision. We want to be trustworthy. How do you get to be trustworthy? Well, you need to have some disciplines. And what is craftsmanship? Craftsmanship is a bunch of disciplines. It's a bunch of promises that you make to yourself. A little bit later, I will walk through a set of such promises that I think might be representative, and I'll leave it to you. These promises are promises that I make to myself. And then secondly, I make them to the community that I am a part of. They are promises about the way I behave. What are those promises based on? What basic disciplines do they come from? I love technology. Let's see now, what do you think the computer is doing right now? I think it needs to be rebooted. What was it doing? What was that projector doing, right? The signals were going in. So what was it doing? Well, it had to hunt, right? Because there's a whole bunch of possible signals that it could be receiving. So it's got to hunt through them all, and it can't just go, this one, this one, this one. No, it's got to wait for each one to see if that one is the right one. And, that's not the right one. Okay, we got to try this one. That's not the right one. We got to try this one over here. And meanwhile, you're sitting there going, maybe I ought to unplug it again. There's this state machine misalignment between the state machine and the projector and the state machine in your head. And unless you know how that state machine works, you're going to screw it up over here. So, okay, I'm a geek, you know. What you're looking at here are the practices of extreme programming. And I bring them up very deliberately because for the last 20 years, this has been the most well-defined set of craftsmanship disciplines, software behavior disciplines that have been enunciated. There have been some others, but as a collective group, as a whole, this is one of the most cogent and intelligent set of disciplines that has been presented. And it formed the core of the Agile movement. And it formed the core of the craftsmanship movement. Because make no mistake about it, the craftsmanship movement is the direct descendant of the Agile movement. How many of you work on an Agile project? You see what I mean. You cannot be in the craftsmanship movement without also being in the Agile movement. And although there are issues there, and I'm not going to belabor those issues today, it's important for us to realize that we are part of this larger community, and you and I, as part of the craftsmanship community, are straining to guide the Agile community as a whole in a good direction. The disciplines you see on the screen here are the core of disciplines that a software craftsman might apply. Most of them, I think, would apply. Look at the inner red circle there. How many of you practice test-driven development? Look at that. Now that's probably half of you, if I counted that properly. The year is 2018. Why isn't it all of you? What's gone wrong? Why is this, why is that still controversial? It shouldn't be. Why is that still controversial? I don't know the answer to that question. It's a puzzle for me. Now, I've been very encouraged that test-driven development has been advancing and more people adopt it. I've also been somewhat discouraged by the fact that articles get published from time to time saying ridiculous things like TDD is dead, or I won't ever do TDD again, or TDD sucks, or whatever. But I wonder now, in 2018, why this isn't the default way that programmers behave. It's certainly the default way that accountants behave. Anyone who wants to make sure that they're not making critical errors in complex documents behaves this way. Why is it that half of us still don't? And by the way, this is a self-selected crowd. You go out into the real software community and you'll find it's about 10%, maybe 10%. What's the issue? Is it really that difficult to believe that we ought to test our code? Is it really that controversial to say that we should write a set of tests that prove our code is not faulty? It's difficult for me to say prove correct, because you can't prove correct. But you can create a set of tests that prove the absence of fault, sort of. So I want to walk you through a set of promises. This is a set of promises that I wrote, several years ago. I called it the programmer's oath. I've called it the scribe's oath. I've called it a whole bunch of things. Just a bunch of promises that have been collected over the years. Promises that a software craftsman can make to themselves and to the community that they're part of. And the first, of course, is I will not produce harmful code. Promise number one, I will not produce harmful code. But in order to make that promise, we have to understand what harmful means. And harmful can have a lot of definitions. First of all, it could be harmful to the society. How many computers are in this room right now? You think hundreds? How many would say thousands? Are there thousands of computers in this room right now? Would anybody say tens of thousands? Could there be tens of thousands of computers in this room right now? How many computers do I have on my body? Somewhere on my body, how many processors are currently executing instructions written by a programmer sitting on my body? Let me roll up my sleeves, because that's not one of them. Okay, there's this, the watch, right? And by the way, just about everybody's watch, whether it's an Apple Watch or not, has some kind of a processor in it nowadays, unless you're a retro guy and you still like winding springs. But okay, how many computers do you think are in this? Is it just one? Or is there a graphics processor and a Bluetooth processor and a main processor and could be an awful lot of processors in here. Of course, I've got my iPhone. How many processors are in this iPhone? There's a lot of them in here. There's a graphics processor, Bluetooth processor, cellular processor, GPS processor, a whole bunch of processors. Loads of little tiny computers in here executing code written by programmers. See, what else have I got? We got AirPods. And each one of these little earpieces has a processor in it, at least one, maybe two. Might be a Bluetooth processor and an audio processor, I'm not quite sure. So there's at least two, and then of course the case has a processor in it. Isn't it weird our cases have processors? By the way, that's true of my iPhone too, because my iPhone sits in this case here, which is a battery charging case, but there's a processor in here that knows how to keep the battery charged and to trickle charge the iPhone and so on. And they wired me up here. There's got to be a processor in this thing, probably several of them. Is anything else on my body that might be executing code? Not my brain. Now count the computers on your body. How many computers are in this room? How many computers were there in 1946? 1. How many computers are in the world today? It must be many billions. I hesitate to do a Saganism. Billions and billions. But I think it must be many billions, maybe many tens of billions, possibly hundreds of billions of computers in the world today, all executing code written by programmers like you and I. And what do these computers do? Everything. Name an activity. Avoid certain biological activities, but name an activity that can be done in our society that does not involve a computer. Nowadays, of course, you cannot buy anything without using a computer, at least the cash register, but probably much more. Nowadays, of course, we go into Amazon, so there's a lot of computers involved. You can't sell anything. No law can be enforced. No law can be passed. No law can be adjudicated. Insurance policies can't be made or settled. You can't make a telephone call without using a computer. You can't watch the TV without using a computer. You can't wash your clothes without using a computer, or the dishes. You can't turn on the air conditioning or the heat in your home. You can't do anything without a computer. You think about how often human beings in Western society interact with a software system. And think of your grandmother, if you have one still. How often does she interact with a software system? And the answer to that is on a minute-by-minute basis, because there is nothing you can do in our society without interacting with a software system. Software has become the blood of society, the circulation system of society. Nothing happens without software. You can't drive a car without software. The traffic lights don't work without software. Airplanes don't fly without software. Trains don't run without software. Nothing happens without software. It didn't used to be that way. But over the last 30 years, software has infiltrated everything. And that infiltration continues to this day. Software is wiggling its way into the most minute parts of our lives, and most human beings do not realize it. Even we programmers don't really realize it. Is there a need for craftsmanship? Think of the depth of our influence. Think of how many lives you and I impact with the code that we write. It's virtually everyone. And lives have begun to depend upon what we do. How many people have died because programmers were careless? The code inside cars. How many cars have fatally crashed because the code inside cars did something stupid like blew the stack? I use the word blow the stack in reference to a fatal accident. Many of you have probably blown the stack from one time or another, because most of us do. But imagine that that kills people. How many fortunes have been lost because a programmer forgot to boot up one particular server? How many terrible situations have occurred because a programmer was careless? And how long will it be until some programmer somewhere does some stupid thing and kills 10,000 people? And you know that's going to happen. It's bound to happen. There's just too much software running around everywhere. So some poor guy, who knows who he is, going to forget a comma somewhere. 10,000 people will die. And of course, the politicians of the world will do what they must. They will rise up in righteous indignation and say, well, something's got to be done about these software people. And you might hope that they'll get the managers of the software team up on stage and say, you managers screwed up. But we saw what happened when the CEO of Volkswagen North America was called before the Senate of the United States and asked, how could this have happened? How could you have let this code get written that cheated the environmental machines? And the CEO of Volkswagen North America stated, and I quote, well, it was just a couple of software developers who did it for whatever reason. The finger will not go to the managers. Oh, it might, but it'll get deflected right towards us. And it should, because it's our fingers on the keyboard. You see, it was a couple of software developers at Volkswagen who wrote that lying, cheating code. And whether they were told to or not is irrelevant. Whether it was part of their job to do it is irrelevant. If you write lying, cheating code because your boss told you to, it's still your fault. And you should go to jail, as the developers at Volkswagen have done. I will not produce harmful code. It's a big call. That's a big, big promise. What kind of harm? Well, that's the one kind of harm. Let's not kill anybody. Let's not make anybody sick. Let's not lose fortunes. But let's narrow the scope a little bit. We're working on systems. We're working on products. Our code should not harm the business that is paying us to build this software. So we want to make sure that the code executes properly, behaves properly, does the right things. But there's another kind of harm. Because software is a compound word. And the first word in that compound word is soft, which means changeable. The reason software exists is because we needed a way to easily change the behavior of our machines. We had machines already. We just needed to be able to change their behavior easily. And it's very hard to change the behavior of a machine with a soldering iron or a bunch of gears. But if you have software, you can very easily change the behavior of the machine. That's why software exists. And therefore, if you do anything to the software that makes it hard to change, you have thwarted the reason software exists. You have harmed the company you work for. You have harmed the system you are working on. So this idea of harm goes very far. It covers a lot of ground. You will not harm the people that use your system. You will not harm the employers who have paid you to produce that system. You will not harm the customers who bought the system from your employers. You will not harm your employer by putting bugs in the code or leaving bugs in the code. You will not harm your system by making it inflexible and unmaintainable. You will not make a mess. And you might complain and say, yes, but we have deadlines. Well, yeah, everybody's got deadlines. That doesn't alleviate the need for you not to harm. Has anybody released code that they knew was harmful? In some extent. It wasn't the best code they could have produced. They knew maybe it didn't have all the right behaviors. Maybe it had some minor bugs. Anybody release that and think, well, it's okay because I had to meet the deadline? Now, maybe it was okay because you had to meet the deadline, but did you tell anybody? Did everybody know, listen, we can release this, but here's what's going on inside this code? Or did you kind of cross your fingers and say, well, geez, I hope nobody discovers that? Promise number 2. This is a hard one. code I produce will always be my best work. It's a real hard one, because you will be tempted to not do your best work. Other things are going to get in the way and say, I can't do my best work. I've got to do less than my best work because there's some other constraint I need to meet, like a deadline or something like that. I will not knowingly allow code that is defective either in behavior or structure to accumulate. I worded it this way because you are going to produce code that is defective in behavior and structure from time to time, because we are imperfect creatures. We write code, we think it's pretty good. Later on, we look at it and go, my God, that sucks. I don't believe I wrote that. And once you make that realization, then you must not allow it to accumulate. You must go back and fix it or refactor it. By the way, as I am reading these promises, I want you to keep that circle of extreme programming practices in your mind, and notice that every one of these promises is just a restatement of one of those practices. If I'm going to be producing the best work I can all the time, and that's not the best work, it's just the best work that I can. If I'm going to be doing that, then I'm going to have to be going over the code all the time, looking at it, refactoring it, improving it, tweaking it, adding new tests, adding new structures, trying to make it better all the time. I am going to craft the code. I am going to apply disciplines to the way I work. I'm not going to write the code. Who's done this, right? You're writing the code, and you can't get it to work. Try this, try that. It doesn't work. It doesn't work. The clock is ticking. Try this, try that. Oh, God, it works. All right, don't touch it. No, you don't do that. No. See, programs are hard enough to get to work. We will not write clean code. No one writes clean code. When we write code to make it work, that code is always awful, because it's hard enough to write code that actually behaves. But once you've gotten it to where it behaves, once you've gotten it to the point where it actually works, then you step back and say, okay, but it sucks. Now, how can I make it better? How can I restructure it? How many of you have written code in a stream of consciousness, right? So you start out with a function, you say, all right, I got to get the account. All right, I'll get the account. Oh, God, I need a string buffer. Okay, get a string buffer. Okay, now, get the account number. Oh, God, it might be null, if null. Okay, it's not null. Okay, I need to gain access to the amount. Count that amount. I have to deposit something in there, and I've got to get the deposit. Oh, that could be null, if null. This is the way you think, right? This is the way we all think. When we're writing code, we're solving the problem, and this thread of consciousness goes weaving in and out through levels of detail, all the way from the highest level concepts in the system down to nulls and if statements and dots and stupid stuff, details way the hell down. And we're zigzagging our way through trying to get it to work, and then we get it to work, and we go, okay, now comes the hard part. That was the easy part. The hard part is to say, okay, now, can I rearrange this code so that it will make sense to someone else, so that I don't force someone else to go through that horrible zigzaggy process in and out of abstraction levels? Can I make this code express itself? Can I make it explanatory so that someone else can look at it and go, oh yeah, that's exactly what it does? Ward Cunningham once said, clean code. You know you're dealing with clean code when each routine you read is pretty much what you expected. When's the last time you read code and it was pretty much what you expected? And by that I mean you're reading it and going, yeah, yes, 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 yep. Most of the time we read code and go, oh, what the fuck? is going on in there? You don't allow that to accumulate. You may write it, and you clean it. 3, I will produce with each release a quick, sure, repeatable proof that every element of the code works as it should. A quick, sure, repeatable proof that every element of the code works as it should. Now, if you're someone in the outside world, like your grandmother, well, that would just go without saying. Well, the people who write programs, they prove that they work, don't they? Well, of course they do, because, I mean, I get in my car and I drive it, and there's software in my car. Of course they prove that it works. I fly in an airplane. And of course the people who write, they prove that it works. I go to the store and I give them money in the cash register. The people who developed the code in there, they proved that it worked, right? Of course our users expect that we have done this. Not only that we have done it, but that we can prove it over and over again. At a moment's notice, someone should be able to come to us and say, prove that works. Think of what we make. We make these documents. They're huge. Massive documents full of arcane symbols that no one can understand but us. And everybody else who uses them goes, can you prove that works? If they could see the code, if they could see the complexity of it, if they could see the intricate nature of all the symbols that we try to manipulate on this source code, they would react in horror. So I didn't know it was like that. How do you know that works? Well, that's one hell of a good question. And the answer to that, of course, is that we write tests. We do exactly what accountants do. Because accountants have the same problem. They manipulate really big documents full of arcane symbols that no one understands except them, and terrible things happen if they're wrong. And so they enter every transaction into the books twice. Just like we do, of course, when we're doing test-driven development. We enter everything twice. Because test-driven development is just our answer to the accountant's discipline of double-entry bookkeeping. Accountants produce a quick, sure, and repeatable proof that the accounts they are accounting for are balanced. That's part of the normal business practice. Every executive gets a balance sheet. On that balance sheet, there is a 0. And that 0 means 0 tests failed. Every transaction balanced. Don't you think your CEO should get a balance sheet from the programmers? 0 tests failed. Four, I will make frequent small releases so that I do not impede the progress of others. It is tempting in the software world to take out a branch and then work on that branch for months and then try to integrate that branch back into the main line months later, and you know, chaos ensues thereafter and everybody gets stuck and, oh my God, the integration is terrible. I want frequent small releases. I want you to be checking in code daily, hourly. I want integration to be continuous. I don't want you holding out a whole bunch of code and then at the last minute dumping it on us and saying, my code is great, now go integrate it while I get beer. But frequent small releases is more than just code. Frequent small releases is everything. I want frequent small releases of the requirements. I don't want a great big requirements document. I don't want the programmers to sit there and go, we cannot begin until there is a complete requirements document that specifies everything. You know, we used to do that, right? It was programmers who made those demands. If you think about the waterfall process and how awful the waterfall process was, but you must understand that it was the programmers who were demanding the massive requirements document. It was the programmers who were saying, now we can't even start. So we know everything is done, because then we've got to derive the architecture and the design. We've got to do all this stuff. That's a bad attitude. So I want frequent small releases, regardless of how high or low in the hierarchy we go. I want frequent small releases of everything, because that is the only way to get feedback. One of the extreme programming values, feedback. What are the 4 values of extreme programming? Anybody remember? Courage. Communication, simplicity, and feedback. And I like to replace communication with honesty.
There's also respect.
And there's respect. That would be nice, although that's part of honesty. Five, I will fearlessly and relentlessly improve our work at every opportunity. I will never allow it to degrade. Perhaps the most important part of that one is the last sentence. I will never allow it to degrade. Have you ever seen software degrade? Have you ever seen the structure of a software system rot like a piece of bad meat? Getting worse and worse and worse with time. How can that happen? Software is not a biological substance that bacteria can invade. How is it that software systems rot with time, becoming ever more tangled and ever more corrupt? How does that happen? Well, obviously, it's us who's doing it. You know, our fingers are on the keyboard. We are the bacteria that rot the code. But why? Why do we rot the code? No, nobody wants to rot the code. Why do we rot the code? And I'll tell you why. Because it's really easy. How many of you have brought code up on a screen and you look at it and say, it's rotten, it's awful, I should clean it. And your next thought is, I'm not touching it. Because you know if you touch it, you will break it. And if you break it, it becomes yours. So you walk away. Not me. I'm not going to be the one to touch that code. Somebody else can clean that code. If this is the way you react in fear, then the only thing that can happen to that code is that it will rot. No one will ever do anything to make it better. The only thing that will happen to it is that people will go into that code when they absolutely must and do the absolute least to fix a bug or add a feature and get out as soon as they can because they're terrified. And I want you to think about how wildly irresponsible it is to be afraid of the thing you created, to have allowed it so far out of your control that you don't know what it's going to do when you change a line of code. Has anybody had that fear? You know, God, I don't know what's going to happen if I change that line. It could be anything. Right? Who's had the experience of changing an obvious, simple line of code, just clear as day, and it did exactly what you thought it was going to do. It fixed whatever problem or added new whatever feature, but something over there broke. Some completely unrelated part of the system broke. Why? Because of some strange, weird dependency that had crept through the code, and that weird dependency was the outcome of a bunch of rot. How do you prevent that? How do you stop the rot? Well, you've got to get rid of the fear. You can't stop the rot if you're afraid. So you've got to get rid of the fear. How do you get rid of the fear? Well, imagine that you had a suite of tests. A suite of tests that you trust with your life. Literally, you know. You trust this suite of tests with your job. And then you look at the code on the screen and you say, well, man, that's messy. Somebody should clean it. I think I'll clean it. And you change the name of a variable. And you run the tests. It didn't break anything. Okay. I'll break that function in half. Now it's 2 functions. Run the tests. It passed. Good. It didn't break anything. Take that function and move it into that class over there. Run the tests. Broke. Put it back. Okay. Oh, yeah, green. All right. Runs again. Oh, I see what I did. I meant to move it over here. Run the tests. If you had those tests cleaning would be easy, natural. You would want to do it. It would make your life easier if you had those tests. Why don't you have them? Okay, everybody can say, yeah, well, I'm on a legacy system and nobody wrote tests. Fine. But are you making the problem better or worse today? 6, I will do all that I can to keep the productivity of myself and others as high as possible, and I will do nothing that decreases that productivity. There's a lot of ways that you could spin this one. One good way to decrease productivity is to omit one test. Just not write one. You know, why would you not write a test? By the way, who writes tests after the fact? You write the code first and then you write the tests. And you thought that was test-driven development. Never mind. How much fun is that, to write the tests after the fact? It's not a lot of fun, right? Because you already know the code works. You've tested it manually. Why would you write these tests after the fact, after you've tested the whole thing manually? Well, some process weenie told you you had to, so they guilt you into writing a bunch of tests. And so you write this test, and your attitude is, okay, I'll write that test. It passes. I knew it would. And I write that test. It passes. I knew it would. And you inevitably come across the function that's hard to test. It's hard to test because it's coupled into the system in bizarre ways. And you did not write the test first. And therefore, you did not design the system to be testable. And therefore, you come across the function that's hard to test, and you look at it and go, oh, man, I'm going to have to restructure this and restructure that to make it work. And I know it works. I tested it manually, and I've got other things to do, and yeah, whatever. And you walk away, and you leave a hole in the test suite. And you know if you're doing it, everybody else is doing it. How can you trust that test suite? If you know there's holes in it, if you're putting the holes in and other people are putting the holes in, how can you trust that test suite? How many of you have a test suite and you execute it and it passes and your reaction is, yeah, it passed. Well, that's a worthless test suite. That's a worthless test suite. It's sometimes worthwhile because it can catch a malfunction. It'll fail if there's a horrible malfunction. But when it doesn't fail, when it passes, it provides you no information, no decision you can make on passing. And the test suite you want is the test suite that allows you to make a decision when it passes. And the decision is ship. This thing is shippable. I can ship this because these tests pass. That's the decision you want. Or the decision is, I haven't broken it. I can refactor. I can clean it. I haven't broken it. That's the decision you want to be able to make with a test suite. A test suite that doesn't allow you to make that decision is almost entirely worthless compared to the effort of creating it. That's one way to decrease productivity, just leave holes in the test suite. Another way to decrease productivity is to not clean the code, to just continue to add massive amounts of code without refactoring. That will decrease productivity. Of course, another way to decrease productivity is to just be an asshole in your team. Don't do that. 7, I will continually ensure that others can cover for me and that I can cover for them. How does a team behave? You got a bunch of guys. They're kicking the ball down the field, right? They're attacking the opponents. They're trying to block them, but they've got a whole rhythm down. They're passing it back and forth. They're moving it down the field. Everything's going great. And then all of a sudden, one of the players goes down. Trips, falls. He's not injured. It's fine. He's waving, saying, no problem. What do the other players do on his team or her team? They change their field positions. They cover the hole. They keep the ball going down the field. That's how a team behaves. When a team member goes down, the team covers and keeps the ball moving down the field. Are you a team? Do you behave like a team? If you are a team, you must be able to cover for each other. When Bill goes down because he's gotten sick or he's got a fight with his wife or God knows what, does the team still make progress? Is Bill the only guy who knows the database? Oh, God, Bill's not here. We can't make progress today. Anybody got one of those? Oh, the GUI guy's not here. Man, can't do a thing. That's stupid. Why would you allow something like that? Why would you allow those silos to block you? You need to be able to cover for the guy who goes down. So how do you cover for the guy who goes down? Well, you better work with him. How do I make sure that you can cover for me? Well, I got to get you to sit down next to me, and we need to write code together in the environment that you're going to try and cover if I go down. We talk about the practice of pair programming, and a lot of people get all controversial about pair programming. I don't know how to pair program this or pair program. The reason we pair is that we know how to cover for each other if something bad happens. That is the fundamental reason behind pair programming, so that we can actually be a team and cover for each other. 8, I will produce estimates that are honest, both in magnitude and precision, and I will not make promises without certainty. Who's good at estimating? That's the right answer. Good. All right. Nobody's good at estimating. Quite right. So we have to be able to estimate. And a lot of people have said, this agile stuff is all about not estimating. No, that's wrong. We do have to estimate. And the estimates we create for our employers have to be honest and as accurate as possible in both magnitude and precision. As possible is the key there. So what is the most honest estimate you can make? 3 little words. I don't know. How long is it going to take you to do this? I don't know. Now, that's honest. It's not particularly useful. And there are some things that you do know. So I want you to add to that I don't know with some other information. For example, well, look, if everything goes like perfect, I can get this done in a week. If everything goes the way it usually goes, well, it's going to take 3 weeks. And then, if things really just go to hell, well, it might take me 10 weeks. That's honest. And it is honest in a very interesting way because it describes the shape of your uncertainty. It's another way of saying I don't know, but it provides a shape to I don't know. And it's a shape that managers can use. They can go back from that and say, oh, okay. First of all, how the heck do I make sure that everything goes well? Because I'd really like that 1-week outcome. 2, I got to prepare for the 10-week outcome because things sometimes do go to hell. That's the most honest thing you can say to a manager. If everything goes great, this. If everything goes to hell, that. And usually this. Now, managers aren't going to like that because managers don't want to manage. Right? Management is the dealing with uncertainty. That's what management is, dealing with uncertainty, making sure the probabilities line up, making sure commitments are specified properly. Management is all about dealing with the uncertainties of business. And you are providing this uncertainty. And managers don't want any more uncertainty than they need because it's hard to manage uncertainty. So they will try to push that back on you and say, well, you've got to do better than that. Come on. You can do better than that. I mean, just assume everything's going to go normally, right? So then it'll be 3 weeks, right? No, because, sometimes. Well, I got sick last week. Don't play the funny game. And the funny game is this. Yeah, okay, I think it'll be all right. I'll get it done in 3 weeks. Don't worry about it. That's lying. You are now lying. You have removed the uncertainty, and the uncertainty is absolutely necessary for the manager to do their job. And you have now made it impossible for the manager to do their job by lying to them. Now, you will find that this is a difficult negotiation because managers are still going to push back. Says, come on, you can do better than this. Or, work harder. Give me a better number. And you may come back and say, look, there's no better number I can give you. Look, it's 1, 3, and 10. That's the best I can do. And then in frustration, the manager will say, well, will you at least try? And the answer to that is, how dare you suggest that I am not trying? No, don't do that. But that should be what's in your thoughts. How dare you suggest that I am not trying? I'm a craftsman. I have disciplines. I'm a professional. Of course I'm trying. How can you even suggest that I am not trying? Now, you want to be a little more gentle than that. But I mean, the simple way to say that is, no, I can't try anymore. I'm trying as hard as I can now. 1, 3, and 10, that is what trying looks like. It's very easy to say, oh yeah, I'll try, don't worry. And that's just another lie. And the problem that we have as software developers is that we tend to lie an awful lot when it comes to estimates. Because we don't want the confrontation. You know, you and I, programmers, we didn't get into this business because we like people. So negotiating with people in a confrontational environment is just not a lot of fun, right? We'd rather go back to the code because you don't have to argue with the code, you just have to struggle with it. You know. 9. And the final one. I will never stop learning and improving my craft. The software craftsmanship movement got its first impetus, I think it was 99 or 98. Pete McBreen wrote a book called Software Craftsmanship. Anybody remember that book? And what he described in that book is very different from what you and I are now talking about, except for one thing. Pete McBreen's book was about apprenticeship. It was about the model that was used in the Middle Ages, about how you take junior people and advance them to become senior people. And you do that by hands-on mentoring. You have apprentices, and they become journeymen, and the journeymen then become masters. That was his model, and it's an old model. We in our society have decided that that's not what we want to do, right? And in our society, you go to college, and when you come out of college, you're an expert. How many of you learned to program at home and then went to college and got a degree but didn't learn much? Yes, okay. The universities are not actually equipped to train software developers to be software developers. They can teach you how to write a little bit of code here and there. They also teach a lot of very bad habits like, get the project done at the last 10 minutes before the, that kind of thing. Every college student does and then emulates in the work. How many of you came out of university, got a job, and thought, this isn't anything like college? So the universities are not prepared to train. And the reason for that, by the way, is the professors have never worked professionally in software, right? Most of them. Some have, but most of them have not. So they really don't know how to train you. What we like to do is continuously mentor each other, continuously train each other and teach each other. And you never stop learning, because there's a lot to learn, and nobody can learn it all. Never stop improving the craft. And you know the best way to learn? Does anybody know the secret, the best way to learn anything? Teach it. That's the best way to learn anything, because all of a sudden you're on the hook to know it and convey that information. You know the best teachers stay one day ahead of their students. In the book, just one day ahead. That's all you got to do. The best way to learn is to teach. And with that, I think I'm done. Thank you all for your attention.